Hello everyone, this is Ibrahim Absalam. This is exercise number 2 in PCB design using Eagle. In this design we will build a 12 voltage, 5 voltage and minus 12 voltage power supply, and I will show you more new tricks. Let's open Eagle, and this time I will use Eagle version 9.6. Open, File, New, Schematic. Will have a transformer 220 volt to 012 AC output voltage, so I will need 3 terminals connected. I will forward by direct rectifier, then 2 capacitors, then I will need 3 voltage regulator, one for the 12 voltage, one for the 5 voltage, and the other for the negative 12 voltage, and the end I will use a connector 4 terminal to get my DC out. From add parts, okay, from connector I will search for COM. Okay, from connector I search for COM BTR 500. I will need 3 terminals. This is the one I need. Okay, and I will need the 4 terminals for the DC output. Let's place it here. Then I will need a rectifier bridge. Rectifier must be this one, the circle half ampere one. This is the one. I rotate it by right click. Then I will need 2 capacitors, RCL, polarized. Screw until I found suitable one. One here, one there, and then the 3 voltage regulators. VR voltage regulator. I will need 278 and 179. Okay, finally we'll need 3 small size capacitors to smooth up the DC output from each regulator. Just we'll search for RCL, RC, and these capacitors will be non-polarized. That's the one. Okay, from the value I will add the value. This one 2200 microfarad, 2200 microfarad. This one 0.1 microfarad. Same for this two, 0.1 microfarad. Nice. Now we need to name everything, so label AC. Next one I will call it AC input, and here DC output. It would be 7812. It would be 7805. The last one 79 12. This is a negative voltage regulator. Now let's connect our circuit. I'll just move it a little bit closer. I will use the net tool. The positive, and here's the negative. This is the ground. I give it a name. I will call it ground. I will connect it here. This is the ground. Back to the net tool. The ground. Same thing I will do. I'll give it a name. It's called the ground. Good. So everything connected to the ground is now named ground. That's what I need. Here is the ground, and that's the input. Output from 7812 will go input for 7805. This pin will connect it here, and this for the 5 voltage, and this is for the negative 12, and we connect the AC negative. Good. We now need to connect the small capacitors. Let's say C3. Sorry, I will use the moving tool. Just near to the cross and connect C3 here. C4 between sorry, here is C4. Okay, we finished drawing our schematic. Let's go to our board. We can press here to switch to yes. First, we place our component in a suitable way. I will use the move tool. Just cross to close here. Just here's its output. Rectifier. Okay, this place is nice. The positive capacitor. G2. We need to add the 3 voltage regulators now. This is the positive 12, negative positive 5 and negative 12 capacitor. Let's add the capacitor C3. We place it here, and C4, it will be here. Finally C5. We noted that the output here, so this is negative 12, ground 5, and so on. Now we finish placing our components here. As you can see, you can use the route tools to just move to bottom layer to connect your traces. This just makes the width suitable, 0.8 millimeter, and starting wire by wire. However, this process will be too hard and take much time. So especially if you have much tracks like this board, so we have a nice trick. We call it auto route. From tools, you select auto route. We don't need a top layer, we just need a bottom layer, so we write here none, and auto, or okay, keep it auto and press continue. Start. The autoroute will do this job for you, and end job. Okay. The good thing, the autoroute finished the traces for you. However, you can see here the widths of the tracks are too thin comparing to this one. Also, the displacement between the tracks are too low. If we have a closer look here, you can see here we have a wire here and wire here and wire there, and they are too close to each other. So it's a problem when we building our in the fabrication. Sometimes it can't do this for you. So to solve this problem, we'll use another tool. We call it DRC. First, the clearance issue, we can solve it by make it wider, so it will be 0.8 millimeter. So this widening, this displacement is nice. Just copy paste it everywhere. And the size, the minimum wire size, it will be also 0.8 millimeter. The drill size 0.8 millimeter in case if we need a drill. Okay, apply, close. Now we need to delete all of this tracks, rip up all signals, and we'll do autoroute again from tools, autoroute, none, bottom layer, okay, continue, start job, end job. The good thing now, sorry, don't ask again. The good thing now is the tracks has a suitable size. The displacement, now you can see here, the displacement is good, so it's ready for fabrication. Now we need to do the polygon for the copper layer. The insulation is 0.8, same, and the angle is 90, so let's draw it. Okay. Give it name round. Yes, we have extra here. And I'll use the redness. Now, as you see, once we have finished, everything related to ground are connected together. Now we can generate the Gerber file for the PCB fabrication. Just save this project, and here from CAM processor, click from the Gerber, choose the suitable one. Gerber RS247X, this is the one we do, and process job. Folder, select folder, same folder, and it's okay. Here's its Gerber files, so you can see here's the Gerbers we have. We can use the Gerber logic to see the output. Simply drag and drop in Gerber logic. Drill. Okay, now we can see our PCB and the Gerber file. Hope you enjoyed, and thank you, and bye bye.